Hello, geometry students. In this lesson, we are going to learn how to use our new trigonometry skills to solve problems that involve angles of elevation or angles of depression. So let's first of all define what an angle of elevation or an angle of depression is. Well, first of all, you need to remember that anytime you have an angle, that angle has two sides to it. So an angle of elevation or an angle of depression is formed by one side being what we call a line of sight. And a line of sight is simply, if you can imagine, like in this picture, we have, here's the Eiffel Tower, and here's a bug. Now, either this picture has not been drawn to scale, or the bug is in the foreground, and the Eiffel Tower is in the background. Otherwise, this would be a gargantuan bug. But anyway, if we have a bug on the ground and he is looking up at the top of the Eiffel Tower, if you can imagine a line that goes from his eyeballs to the top of the Eiffel Tower, that line is what we call the line of sight. Now, we could also have a bird or something sitting on top of the Eiffel Tower looking down at the bug. Again, a line, imaginary line that would go from the bird's eyeballs to the bug, that is what we call a line of sight. So one side of your angle of elevation or angle of depression is what we call a line of sight. The other line will always, always, always be a horizontal line. Okay, so that's really important to remember, that anytime you're talking about an angle of elevation or angle of depression, one of the lines that forms that angle will always be a horizontal line. So if you'll notice here, we call this angle, let me just put an arc on it, we call this angle an angle of depression because it's formed by a line of sight of a bird or something looking down at the ground and this dotted line which is horizontal, okay? So an angle of depression is formed by a horizontal line and a line of sight when something or someone is looking down at the ground. An angle of elevation, on the other hand, is formed by a horizontal line. Now, that's usually going to be the ground, and then the line of sight while a bug or somebody is looking up at something, that line of sight. Now, one thing I want you to notice is that these horizontal lines that form the angles of depression and the angles of elevation would be parallel. If they're horizontal, they're parallel to each other. And so what do we have? We have some parallel lines that are cut by a transversal. So these angles, one being an angle of depression and one being an angle of elevation, would be congruent to each other. Remember, when parallel lines are cut by a transversal, then alternate interior angles are going to be congruent to each other. Okay, so now that we know what an angle of depression and angle of elevation is, let's take a look at some examples. Okay, in each of these examples, the directions are going to tell us to sketch a diagram and then solve the problem. So this first example says an air traffic controller sights a plane at an angle of elevation of 41 degrees. The plane's altitude is 4,000 feet. And then to the nearest foot, we're asked this question: what is the horizontal distance between the plane and the control tower? Okay, so we're going to imagine somebody from the control tower. Now, we're going to go ahead and assume that this is a line of sight that's from the ground. So if the angle of elevation is 41 degrees, then imagine a line of sight as you're looking up at a plane, okay? Here's my attempt to draw a plane. Okay, so pretend like that's a plane. If you're looking up at that plane, then the angle of elevation would be formed by this line of sight, and then we need a horizontal line. So we'll just let that be the horizontal line that represents the ground. Okay, so that horizontal line, I made it a little bit too long. Let me shorten that just a bit. Okay, that horizontal line and this line of sight form an angle of elevation, and that angle of elevation, we're told, is 41 degrees. Okay? Now, another piece of information we're given is that the plane's altitude is 4,000 feet. So what we're going to do is from this plane, we are going to drop a perpendicular down to the ground, because remember, the definition of the shortest distance from a point to a line, in this case the plane to the ground, would be the measure of the segment that is perpendicular to the ground. So drop that perpendicular, and that gives us a right triangle. So now that plane's altitude is 4,000 feet, And then oops, I'm missing a 0. There we go. 4,000 feet. And then we are asked to find what is the horizontal distance between the plane and the control tower, which would be here in the plane. So that horizontal distance would be this distance along the line, the horizontal line. So since we don't know that, let's go ahead and call that x, okay? So now we can use our trigonometry skills to find out what x is. So what we're going to do is base our thinking on this 41-degree angle. Now, with respect to this 41-degree angle, we know this side, which we're going to call the opposite side. Okay, the leg, let's call it the opposite leg, the leg that's opposite the 41-degree angle. We also, and then we're being asked to find this segment, which is the adjacent leg. So let me label that as adjacent. All right, so now what we need is to write an equation that involves a trig ratio that involves an angle, its opposite side, and its adjacent side. So you'll recall in class we used the mnemonic device SOHCAHTOA, which is SOHCAHTOA. That's not really a word, it's just a bunch of letters that help you remember that the sine of an angle is the ratio of the measure of the opposite side to the hypotenuse. Okay, the cosine of an angle is the measure of the adjacent side to the hypotenuse, and then the tangent of an angle is the ratio of the opposite side to adjacent. So that's what we're going to use here, because with respect to this 41-degree angle, we know the opposite side and we're going to find the adjacent side. So let's write an equation, and it would look like this. First of all, I'm going to write tangent, and if I write tangent, that should be followed by the measure of an angle. So the argument of a tangent function is an angle. So the tangent of a 41-degree angle is equal to the opposite side to over the adjacent side. So in this case, that would be 4,000 over x. Now you'll remember in class we talked about what to do when this denominator is, when the variable is in the denominator. So what we can do is we can just take x and tangent 41, and those just switch places. One thing you could do is you could put tangent over 41 and cross multiply, or tangent 41 over 1 and cross multiply, and you'd end up in the same place where x is equal to 4,000 divided by the tangent of a 41-degree angle. So at this point, you'd grab a calculator. You would make sure that that calculator is in degree mode, and then you're just going to take 4,000 and divide it by the tangent of 41 degrees. Now you'll notice it says to the nearest foot. So when you get your answer, make sure you round it to the nearest foot. And so our answer would be x is approximately 4,601 feet. All right, and that's our first example. Okay, our second example says the following. It says a forest ranger in an observation tower sees a fire. The angle of depression to the fire is 7 degrees, and then the question is, how tall is the tower if the distance from the ranger to the fire is about 739 feet? All right, so let's draw a picture of what's going on. So first of all, we have a ranger on top of a fire tower. So I'm going to attempt to draw, here's our tower, all right? And here's the ranger on top of that. Now, he has a line of sight down to a fire. So here's the fire happening, okay? Now, it says, the problem says, the forest ranger he sees a fire. The angle of depression is 7 degrees, okay? So here's the ranger looking down at this fire, and here's a mistake that a lot of students make. When they're dealing with an angle of depression, a lot of students will say that this is your 7-degree angle, your angle of depression. Well, that is incorrect, because remember how we defined an angle of depression. It's always going to be formed by a line of sight and a horizontal line. So I'm going to erase this because that is incorrect. That is not our angle of depression. What we have to do is we need to actually draw a horizontal line. So I just usually make it a dotted line. Okay, so there's our horizontal line, our line that would be parallel to the ground. That is our 7-degree angle, okay? Now let's see what else we're given and what we're asked to find. It says, how tall is the tower? So let's call that measure x, okay? How tall is the tower? let's see, how tall, if the distance from the ranger to the fire is 739 feet. So the distance from the ranger to the fire, that would be the measure of this, what's going to be our hypotenuse in just a minute. That measure is 739 feet. Okay, now let's finish a couple things. Let's go ahead and draw the ground, and then we need to make the assumption, I didn't draw it very well, but let's make the assumption that the tower is perpendicular to the ground, so we have a right triangle to work with. Okay, so to find x, okay, we need to use one of these acute angles of the right triangle. Right now we don't have any of them labeled, but remember, the ground is parallel to this dotted horizontal line. So when we have parallel lines cut by a transversal, alternate interior angles are congruent. So this angle is also a 7-degree angle. So we're going to work with that 7-degree angle to write an equation involving a trig ratio. So with respect to the 7-degree angle, we're looking for x, which is the leg that's opposite the 7-degree angle. So I'm gonna label that. That's our opposite leg. And then what we're being asked to find is how tall the tower. Oh, that's what we're being asked to find. And then we're also given this measure, which is 739. That's the measure of the hypotenuse of this right triangle. So now we need to write an equation that involves a trig ratio, and the trig ratio that involves opposite and hypotenuse, that would be the sine trig ratio, because sine is the ratio of the measure of the opposite side to the measure of the hypotenuse. So let's write an equation. We're going to say that the sine of our 7-degree angle, anytime you write sine, cosine, or tangent, make sure your argument is the measure of an angle, is equal to the measure of the opposite side. Well, that would be x to the hypotenuse, which is 739. So that would be x over 739. So you can see that this equation is very simple to solve. All we need to do is multiply both sides by 739. So grab a calculator, make sure it's in degree mode. You're going to take 739 times the sine of 7 degrees, and we're going to get x to be approximately 90 feet. I'm going to go ahead and round that to the nearest foot, just from the context of the problem that says that the distance from the ranger to the fire is about 739 feet. So since this measure was rounded to the nearest foot, we're going to round our height of the height of the tower. We're going to round that to 90 feet. All right, so let's take a look at one more example then. This last example says a pilot flying at an altitude of 2.7 kilometers sights 2 control towers on the ground ahead of him. Then it says the angles of depression to the bases of the 2 towers are 37 degrees and 58 degrees. And then the question is, what is the distance between the 2 towers to the nearest 1/10 of a kilometer? Okay, so let's draw a picture of what's going on here. First of all, we have a plane. Okay, here is my plane. Use your imagination. And we're told that that plane is 2.7 kilometers. That's its altitude. So we need to drop a perpendicular to the ground. Okay, so here's the ground. And then we can label the altitude of that plane as 2.7 kilometers. Okay, now what he sees is he sees 2 control towers on the ground ahead of him. So there's one here and one here. Okay, so that means that there are 2 lines of sight. There's a line of sight to the first control tower and a line of sight to the second control tower. All right, then we are told that the angles of depression to the bases of the 2 towers are 37 degrees and 58 degrees, okay? So let's talk about those 2 angles of depression. First of all, if you're going to draw an angle of depression, make sure that you draw a horizontal line, because an angle of depression is formed by a horizontal line and a line of sight. So our 2 angles would be then this smaller angle, and then, which I'm going to put 1 arc on, and then this larger angle. So we're told that one of the lines of sight is 37 degrees. Well, that would obviously be this smaller angle, 37 degrees. And then the bigger angle with 2 red arcs, that's our 58-degree angle. Okay, so now what we're asked to find is the distance between the 2 towers. Okay, so to do that, let's first of all find this measure, okay, which we can do by using this right triangle. Okay, we will identify an interior acute angle, write a trig ratio to find this measure. Why don't we call this measure, I'm going to call it X, okay? Then we will find, let me get a different color here. Next we're going to find this measure. I'm going to call it Y, and we'll be able to do that using this right triangle, okay? And then if I take X, this whole measure, minus Y, that will give us the distance that we're being asked to find, which is the distance from one control tower to another, okay? So let's find X first. So let's look at this larger right triangle. And first of all, if I'm going to write a trig ratio, I need an interior angle. So let's use the fact that we have parallel lines cut by a transversal. So this 37-degree angle would be the same as this angle right here. So let's put one arc on that and label it as 37 degrees. Okay. So then with respect to that angle, this 2.7 kilometers would be the opposite side. So I'm going to label that as opposite. And then X, which we want to find, would be the adjacent side. So let me label that as adjacent. All right, and so now we're ready to write a trig ratio. So with respect to this 37 degrees, we're going to use an opposite side and an adjacent side. So opposite and adjacent should make you think of the tangent function, tangent trig ratio. So we're going to say the tangent of our 37-degree angle is equal to the opposite side, which is 2.7, over the adjacent side, excuse me, which is X. So that would be 2.7 over X. So now remember, when you have a variable in the denominator, we can just switch places with the tangent of 37 degrees. So we would have X is equal to 2.7 divided by the tangent of a 37-degree angle. So if you grab a calculator and find that answer to the nearest tenth, it would be 3.6 kilometers. All right, so that has given us an answer for X. What we're going to do now is find an answer for Y, and then we'll take X minus Y, and that will give us this piece. Let me highlight the piece that we're looking for. Would give us this piece right here. Okay, so to find Y, let's look at this smaller triangle, okay, which has, it's going to have an interior angle, an interior acute angle of 58 degrees. Because again, when we have parallel lines cut by this transversal, then let's see, cut by a transversal, then alternate interior angles are going to be congruent. So I'm going to go ahead and label that angle as 58 degrees, okay? And then with respect to that 58-degree angle, we're going to use the opposite side, which is 2.7 kilometers, and the adjacent side, which is Y. So again, since we're taking opposite, comparing opposite and adjacent, we're going to use that tangent trig ratio again. So we will say that the tangent of our 58-degree angle is equal to the opposite over adjacent, so that would be 2.7 over X. So 2.7 over X. And then let's go ahead and let X and tangent of 58 switch places. Oh, you know what? I made a mistake, didn't I? That's not X, that's Y. So let me fix that. It's supposed to be Y. Sorry about that. So let's let tangent of 58 degrees and Y switch places. So we'll say that Y is equal to 2.7 divided by tangent of 58 degrees. So grab a calculator, make sure it's in degree mode, and we would get that Y is equal to approximately 1.7 kilometers. Okay? So now to answer the question, remember the question was find the distance between the two control towers. We're going to take X, which is 3.6, and then we're going to subtract from that Y, which is 1.7, and 3.6 minus 1.7 is 1.9. And then let's put a unit with our answers. 1.9 kilometers would be the distance between these two control towers. Okay, so now that you've seen some examples, you can go ahead and get started on your homework. And it's going to be on page 583. I'll go ahead and post that in Google Classroom. And if you have any questions, be sure and ask me in class.